Hello everybody and welcome to today's webinar in which I will show you how I would use Shaper's sketching and modeling tools to create everything you see under the white body, which is part of a prosthetic design and consultancy project I currently work on for a local prosthetic design company. Before we continue, a few things to set up. As always, we can go to units. We want to make sure that, nope, we're not working with inches, we work with millimeters because we have to work in very small dimensions. So millimeters is very good to work. In appearances, based on preference, you can hide these edges. I keep them for the moment off. And on the lower area here, currently we turn snap to grid off. The way how I will structure today's webinar is simply with this geometry that's already built in as a backdrop. I will show you via sketching over the parts how I would construct all these individual elements. Also in terms of design management and improving your ability to quickly work on particular elements, you want to put nearly every object into a group. So I have the leg, the socket, the bracket, the spacer, and for example the foot. While the foot is made out of two parts, I just put this into one group. Okay, so let's focus on those elements we see here. What is really a good tip is try not to work somewhere off center. Try to really create your sketches and your model so it's nicely centered. For the simple fact, if we now go into the front view and then lower right corner, you see where my pen is. Hello there. There are three icons. To the left, it looks like a piece of cheese with dashed lines. If I tap this one, you will see a cut section view. And that's actually pretty great when we create geometry and then we want to look into everything to see is there any interference. So the way how those were made, you see there are small gaps so they can rotate, because what's not in the model, there are actually some screws that are being pushed into this body, and with this they will actually secure kind of like the angular parts of the foot and the bracket. Okay, so as an easy start, something I always tell my students, if you see a design like this might look very complex. Don't be afraid. Successful 3D modeling is really about trying to break everything down into the most logical elements and then step by step solving one problem after the next one. As a nice warm-up, let's take a look at this spacer. So this is a custom designed piece. I can actually put it to here. There I have it. There you can see there are actually the screws. So this is something you can obviously buy. Prosthetic design, particularly in today's time, when you do something for children who grow, well, you need to figure out how can we create these parts fast, maybe 3D print, which is a really nice technology today. So relying on custom parts is good. Being able to 3D print those and mass produce them quickly is better. I will create a new folder because I will use this as a sketch over. Then I turn on here the cut section. So you will see kind of like what we are trying to do. Now, if we break this down into the individual elements, we have vertical lines, we have some curved elements, and here and there we have kind of like concave surfaces that work like the holder for a socket. So to create this now, I will draw actually the sketch here to the side. So you see a little bit how I step by step do this, and I can move this kind of like to where I need it. and I have the grid turned off, so I'm freely able to move these elements to where I need to. Here I have a line, and didn't mention this before, also auto constraint is turned on. You see this line which I drew straight vertical got a vertical constraint. If you draw this at an angle, not a big deal. Select the line with the pencil, and then on the left there's a horizontal vertical constraint. And we can fix this. Very good. Then I move this one to there. And these two lines I would like to be aligned, so vertically. How do we do this? The lines right now in the new version of Shaper display the midpoints. And I can draw from a midpoint a line to the other midpoint. And when I select this line and make it horizontal, now the two lines, so this one and this one, are vertically justified. Let's bring this one back. This also means if I move this one up and down, you see the other side adjusts. So it's really quick to do this. Here, this looks like a vertical line we have kind of there. So I bring this line to there and there. Get this a little bit closer. Zoom in. For those who are new to Shaper, you see what's really nice with the grid is when you zoom in, it actually gets finer. And now I would like to connect an arc from here to there. So with the pencil, I started drawing from there, and then I wiggle my pen and move this point to the end so it snaps. Very good. And there you see, there we also have this constraint for tangency. In case somebody does not see it, what this means basically is that the arc perfectly tangentially flows into this line, which is what we want. So we can select the arc and the line, click tangent, done. Let's do the same down here. We draw a line, then we draw our arc. The tangency was created, and at this point I can position to there. If I want to, this line, I can give a dimension 3.5. Let's clean this up a little bit. This line on the bottom I can give the same dimension, but to make life a little bit easier, in case I adjust the upper line, I select both lines, and then I will give them the equal constraint. And that basically means the lower line is always as long or equal as the other line. Let's make this one 6, and you see the lower line updated. So it cuts your work by 50% down, which is good. Then from here we draw a line. You notice drawing a line out because I'm working in a cut section view of the 3D geometry. The software tells you it's not so easy. So instead of drawing from this point a line away, I draw from somewhere else and terminate the line at this point. And then, whoops, the upper point I select with the pencil and move to there. Very good. To specify, we can also give this an angle. So with the pencil I select both lines, 165 degrees, and say that's locked. Also here we can give this an aligned dimension. So let's do the same here, 165 for the degree. And then this line and this line. Careful where you click or tap. We make it equal. Very nice. Good. So how do we solve now the arc? I will turn off the spacer group, and then from here draw myself an arc. I can then actually show the spacer again. And I need to adjust the radius now. So I can, with the pencil, drag the arc, and it looks like maybe, let's say 9, 12. Oh, this one moved a little bit. So maybe by hand, via dragging, we can do this 12. Okay. So one little tip, also you notice when I type in a different angle here, the sketch adjusted, see this line moved. To prevent this, I can select this line and on the left add the lock command, and that basically stabilizes that line. So when I add a different angle there, now we have the opposite side, so we have to lock this too, and now we can specify this as needed. So why does this happen? For those who are not familiar with it, and this is a sketch solver. So with all these constraints, what you see on the left side, these icons and dimensions, we try to create a rigid structure. And the solver always tries to, well, solve automatically what it assumes we want to do. That is sometimes very easy to do for the software and sometimes not so easy. So we help it by giving it some extra constraints, like locking these lines, so I can now give a dimension to the degree of that arc. Very good. So let's take a look at the spacer. That's very nice. And what I will do now is I want to revolve that filled blue area, which is a closed shape, into, but before I do this, I need to have a center axis. In my design, I will need to use the axis tool a little bit more. For example, for creating these holes and then rotating them around an axis. And I mentioned before, try to build everything centered on a sketch. So I will add a center axis, construction axis. In this case, no, because I can position this how I want, and I can draw the axis to there and there and there. I snap to the grid. Sometimes it's also good for this task to have the snap to grid turned on, so in case it doesn't snap, so your grid, or not sorry, your grid, your construction lines are not misaligned. They have to be really perfectly at the world center. Let's zoom in a little bit, and yep, it is centered. So this line I created, because now I can go to Tools, then Revolve, select these two filled surfaces, click Next. It asks me on top, select a line or edge for an axis. So here's my construction line, 360 degree, that is what I want, so like a complete pass. Click Done, and there we are. So this was a nice quick introduction into creating this particular part. Let's take a look at how we can create this bracket. But before we continue, get into good habit of naming all your sketches. So right now this says sketch 11 via showing and hiding. I could figure out what that sketch does or what's being used for. Swipe to the left, and then we can give this a logical name, spacer. So let's take a look at this part. This looks pretty complex. It's actually not really complex. So we have 4 holes. We have kind of like a piece of a sphere sitting on there. That's a revolve. Then here this looks like a square with rounded edges, so that's actually a cubical extrusion, and then we later round these edges. And this really looks like a piece of headache. Not really, it's just a basic square, extruded up, tapered, so it gets smaller at the top, and then re-round the respective edges. Okay, so let's do this. How do we start? We didn't really talk about construction planes yet. And this is also a good moment to maybe talk about if you get a CAD model and you have to use it to redesign or further improve on it. We can now be very precise and rebuild something like this pretty closely. I will start with this top square. On this blue face, I will create a construction plane. So go to Add, Construction Plane. I can, with the pencil, select this face. Type offset is good. Click Next. And then we don't offset, simply say 0 and select Done. Very good. With the pencil, we can select now this construction plane and then finger double tap. You can see it snaps to the two-dimensionally to that plane. To prevent interacting with the scan data or the existing computer model, I will hide this for the moment, and I will just somewhere create myself a rectangle. So I did this on purpose, a little bit crooked. Select the line, make this horizontal. This line is horizontal, and then these lines left and right, they have their respective perpendicular constraints. You can keep it this way, or if you rather want to work just with horizontal and vertical, we remove them and then re-add them back. So how do we now center actually this rectangle? Again, I have the snap to grid turned on, and check this out. I draw a line from the Y and the X axis and snap it to the midpoint of these lines. And then this point I lock, this point I lock by selecting the lock icon, horizontal, vertical, perfect. These two lines, they should be the same. Select them, make them equal. And now I can select one point and drag it out, and you see the rectangle scales from the center proportionally. Awesome. Let's go back. We have to go to groups, show our bracket, because I need to now figure out the distance. This construction plane we can now hide. We don't need it for the moment. And we click there and click this line. It tells us, hey, this is 52 millimeters. So the distance between these two lines, which tells me, okay, 52 millimeters, select this line, 52 there. So I don't drag these points till it meets the bracket. If I want to be very precise, I actually measure it and then enter the correct dimension. So we want to extrude this one down, but for how long do we have to do it? Again, here I can select a line, 4.7 millimeters. Let's maybe call this new bracket. I will hide this so I don't interact with it. With the pencil I can select this bracket, this rectangle, and then push and pull this down. There's a dimension, 4.7 millimeters. Let's compare. Yeah, it fits. And if I select this arc, there we also see some of the dimensions, so 10 millimeters. I can use that and memorize it, or in this case, here we try to eyeball it. I select all 4 edges and then with the pencil swipe to the left or the right, switches between fillet and chamfer. And there we see 10 millimeters. That's what we need. There it's rounded. Very easy. Okay, so that's part one. I will make a new group for the moment, so this is not always in my view. I will also hide actually the sketch. I could give this a name, maybe bracket play top. So we don't spend too much time on working clean. I will skip this step and just verbally tell you what you could do to structure everything more efficiently. Now we will do the same with the bottom part and add a construction plane there. Also here 0 and done. So why also did I create these constructions planes? Because I could select a face, double tap, and then it creates a sketch there too. Yeah, so that's possible too. With the construction plane, I always have actually something two-dimensional I could select and then tap to. That's kind of like my preference for it. Now I need to do a little bit of reverse engineering here. So we need to figure out the rectangle we need, and then we need to figure out the angle. Before I continue, in this case, I will go to the front and draw myself not an arc, but not an arc again, just a line. This line, I will maybe put it there, make it a little bit bigger. I will turn the snapping off, and I just try to hit the right angle. I can select the line, move this one in. Yeah, this actually is very close. Good. It's actually the degree 77. Okay, I just wanted to know that. You will see why I did this step first. Where's my construction plane? There it is. Nope. There. Double tap. Okay. So here we will do exactly the same step again. Make some rectangles. I do not have snap to grid turned on. There. And there. Then we lock this dot, Here, horizontal, vertical, horizontal, vertical, and the others are set via perpendicular, equal. I don't really know actually the dimension that much I need, because the edges are rounded, so I have to guess a little bit. So we have to model, and then we can see does it hit or not. But you remember I also created this other sketch with that line. So I need to move this point down till I get to a point where actually this line intersects this line. And then actually I know if I extrude this face up and then taper it, I will hit this surface. This might actually right now sound a little bit complex. So give me a moment to demonstrate that to you. We zoom in a tick more. And then there, I think this is very close. Very good. Okay. Now this I hide. New group is selected. This surface I select, and I'm drafting this up, and this is drafted up much bigger than needed, so I'm overbuilding this. So now we can see how tall it is. And this face now I'm going to scale, go to transform, move, rotate, scale. This is my center point. This should really be at the center of my rectangle because the rectangle was designed symmetrically in my design. This is great. Also here as a little tip, when we have these axes, we can use those for snapping too. And then we zoom in and there's this yellow icon, and that's for scale. And you see by scaling this top face, I'm tapering that surface. There we are. Good. Then let's maybe show this. So there we have a little gap there now. Not a big deal. We also need to create our arc. Because this is metal, this is pretty heavy. For 3D printing, we could keep this more solid. So we will actually cut out, we will create this outer arc and then add a revolve object and then fuse everything together. So to do this, let me just create an arc. I will hide this for the moment. Then here, whoop, I will draw a line to the center. Snap to grid, keep this turned on. Draw a line. I might turn the axis off for the moment. Draw this down. Very good. Now we can try to adjust this as needed. I might turn off the grid again. The snapping, bring this to there. And so I moved this one further up. That's called overbuilding. I want this to intersect with this top area so the volumes don't sit next to each other, but they're kind of like being put into each other. That helps literally a lot of programs to really understand how to do the volume calculations. It's just a really good practice to do that. Okay, now we could refine this a little bit more till we have the right angle. Because we are short on time, I keep it at this. So we can take a look at all those objects we have. Then we go to tools and we go to revolve. You revolve around this line and this and this and this, and there's some things happening. So what will help here is I will make a new group, so I can just select these surfaces, revolve around this edge there. Very good. Then let's turn this one off. Whoops. Take a look at these 2, 3 objects, and we can fuse them all together by going to tools, union 1, 2, 3. Double click, and there you see this is now one object. Cool. Oops. Let's go back to there. And the last thing now we need to do is round, for example, these edges there. Careful what you select. I selected the faces. Then a nice rounded feature there. I only need one edge there. I can just round it as needed. And also here, select one edge because they are tangent to each other. The software understands to run the rounding all around it. So we have kind of like 20 minutes left. That's very good. Because I want to go a step backwards. Do we have all the individual objects? Yeah. So you see that I built everything as individual parts. That helps me a lot, so I can manipulate each individual element, and then when I'm done, fuse everything together. For example, here, this face should, where it meets this line, have a smaller radius than this face.